Okay, so we have learned about geometric sequence. Today our learning intention is to learn about the geometric series. So find how we can calculate sum of n terms of the geometric sequence. So geometric sequence, just remind you, the first term A, we have common ratio R, and so we can write Sn as we do first term A plus what will be the second term? A times R, or R times A plus R squared A plus R in the power n minus 1 times A. That's what we want to find. Any ideas how we can find Sn? What we can do? Yes.
We do
Yeah, not looking how it's done.
n onto a.
Let's how we will find this? How we derive it? Sam, attention should be here. Let's multiply it. Let's multiply by R. So we will get R Sn equal Ra plus R squared A plus plus R in the power of Na.
Why do we start with n minus 1 in the first one? Why do we start as r n minus 1?
Because we are looking for n terms. In first term, r in the power of 0. Now let's subtract. Let's do equation 2 minus equation 1. So we will get r Sn minus Sn equal. Everything, all those terms will be cancelled out, except A plus R in the power of n. Sorry, no, plus will be R in the power of n, A minus A. Can you see everything else when we subtract this minus this minus this, and so on, they all will cancel out. Let's rearrange this formula for Sn. So we have Sn times R minus 1 equal A, R in the power of n minus 1. And finally we get the formula. Sn, sum of the first n terms of the geometric sequence, which is called geometric series, equal A, R in the power of n minus 1 divided by Rn minus 1. Makes sense how we derived it? By the way, there will be questions where you will need to use this approach. Yeah, question?
Just r minus 1? You have Sn and r minus 1, a equals a.
Oh, yeah, sorry. So we have Sn equal R minus 1. Yeah. Of course, it's not n. R minus 1. Yes, thank you. So there will be questions where you will need to use this method. We will go over such questions later on, not today.
Mr. V, wait, how did you just minus Sn to the left side? Sorry.
I do this, we multiply this by R, and that's what we do. Then we do equation 2 minus equation 1. So it's important to understand the method, because there will be questions where you will need to do this method. So we'll go over them later on, not today. Now, if R, the common ratio, modulus R is less than 1, so what we can say about that geometric sequence? If modulus of the common ratio is less than 1,
It's decreasing.
it next term will be smaller, smaller, and smaller. And so we will get that this negative. So for such cases, we're using much as n equal a 1 minus I to the power of n, 1 minus r. Just change sign in numerator and denominator. Now, what if we need to find for decreasing geometric sequence sum to infinity? So we need to calculate sum of all terms, even if it's going to infinity. Why we can do that? Why we can actually calculate the sum on infinitely many terms? Only for this case, when r modulus I is less than 1. What? Yes?
Is it because it's approaching a number?
Yes, because that will be approaching.
Approaching one.
Because that like at some stage, the next term becomes very small. They will be approaching 0. So that will be approaching. So we can calculate the sum. So if we have r modulus r less than 1, what r in the power of n will be equal? And if infinity, we take n approaching infinity. So what will be limit when n approaching infinity, r in the power of n? When r is less than 1, what is limit equal?
0.
0. It's equal 0. So we'll have s to infinity will be equal just a over 1 minus r. So that's how we can find the sum of all terms of the geometric sequence when we have r modulus r less than 1. That's pretty much all theory for today. I'll show you 2 examples and then you do your work. So open your booklet on the page page 14. Please open your booklet on the page 14. And let's consider example 6. Let's consider example 6. We have, I will leave this, but we have that if sum of 1 plus 3x plus 9x squared plus equal 2/3. Find x. Now, what does it mean if we just put plus and dots going to infinity? What it tells us about the common ratio? Can we find sum to infinity for if the common ratio will be greater than 1? No, because it will be increasing all the time. So it tells us that common ratio is less than 1. And what is the common ratio? How we find? We divide second term with the first. So r equals 3x. Can you see that the common ratio 1 times 3x, 3x times 3x again 9x squared. And what is the first term?
1.
1. So let's substitute into this formula. So we have 2/3, sum to infinity equal 2/3, equal 1 divided by 1 minus 3x. So cross multiply, we get 2 minus 6x equal 3. So you get 6x equal -1, x equal -1. 6, check if I did and make some silly mistakes. That's correct. X equal negative 1, 6. Does it make sense how we did it? We just identify what is the common ratio. We identify what is the first term and use the formula to infinity. I think that will be enough explanations for you. You want one more example? I'm more than happy to give it to you. Then on the same page, example 5. On the same page, example 5. The sum of the first 4 terms, so we have S4 equal 13, and sum to infinity equal 32. And it's given that R greater than 0. And we need to find first 3 terms, so we need to find A and 2 more terms. How we will do that? Let's use the formula. So sum of the first 4 terms.
But the formula is only for one R.
Now, as you can see, the R is greater than 0, but we can make another conclusion that it is less than 1.
Okay.
Because otherwise, from sum equal 4 and then to infinity 32, it will not be. So R is less than 1. So we can write S in the power of 4, S4 equal A, first term, which you don't know yet, times 1 minus R in the power of 4 over 1 minus R, and S to infinity, and that's equal S4 equal 13. Then we have S to infinity equal A over 1 minus R, and S to infinity equal 32. So we got 2 simultaneous equations. What will be the easiest way to solve them?
Maybe divide.
Yes. Let's divide equation 2 by equation 1. 2 divide by 1. What happens when we divide? So we get 32 on 30 equal.
1 on 1 minus R.
This will cancels out A over 1 minus R. We eliminated A straight away, so it will be equal. We will have 1 minus R in the power of 4. So,
That's on the bottom.
no. We will have 1 over 1 minus R in the power of 4. So we just need to solve this equation. 32 over 30 simplifies to divide by 2, 16 on 15 equal 1 minus R on 4. So we will get that. So we will have 1 minus R in the power of 4 will be equal 15 on 16. So R in the power of 4.
R is a
Yeah. So I in the power of 4 will be equal 1 minus 15 on 16. I in the power of 4 equal 1/16. R equals 1/2. And to find A, we substituted, easier substituted here. We get 32.
So wait,
Yeah.
does R always have to be positive?
Equation tells us.
Oh, sorry.
Equation tells that R is positive. So 32 equals A divided 1 minus 1/2 divided by 1/2. So A will be equal 16. Okay? So like, subscribe and donate to help fight terrorist countries and organizations, Russia, Iran, Hamas, etc. Support Ukraine and Israel.